So let's see the classification of structures according to the properties they satisfy. On one hand, I am writing the structure, the classification of structure, like what we will call the algebraic structure. So on one hand side, I will write the algebraic structure. Okay. And on other side, I will write the properties that they should satisfy. This is the first structure that we have. This is called magma. This is the name magma. Okay. Some people also call it groupoid, but the popular name is magma. Now let's see what is magma. So this is basically this closure property must be satisfied. That's it, right? So I can say by definition, every algebraic structure is magma. Magma basically means that only the closure property must be satisfied. And you know that closure property is satisfied by every algebraic structure, yes or no? So by default, I can say that every algebraic structure, another name of algebraic structure with single, this magma is basically, remember, this magma, this is basically another name of, algebraic structure with single binary operation. This is another name. This is another name for algebraic structure with the single binary operation. With the single binary operation. So very simple. So that's it. Okay. So this is the name for, means closure property must be satisfied. The another name is if associative property is also satisfied. If with closure property, with this closure property, if associative property is also satisfied, then this will be called semi-group. Then we will call it semi-group. So can I say every semi-group is magma? Can I say every semi-group is magma? Magma means closure property must be satisfied. So yes, every semi-group is magma because every semi-group will satisfy closure property. So I can say semi-group basically means that magma plus associative property. This should be a magma and it should have associative property. Monoid. What is monoid? Monoid basically means semi-group plus identity element. If there is identity element also, so I can say semi-group plus identity element. Plus identity element. Okay. So in the semi-group means with these properties, if you also have identity property, then we will say that this is a monoid. So monoid is very simple, that you have closure property, plus you have associative property and also you have identity property. Then we will say that this is a monoid. The fourth is group, and this is very important. What is group? So group is basically just have inverse property also, very simple. So you have closure property plus associative property plus identity property and plus inverse property. Okay, then these are the four categories: magma, semi-group, and monoid group. Okay, so these are the four categories. Let me tell you one more thing. So magma is basically any algebraic structure with single binary operation, because by binary operation automatically this means closed. Automatically this means closed. These two things are same. Okay, so let's see the next one. Let me tell you one more thing. This person in group theory, in abstract algebra, this person is very popular. There was a mathematician. This mathematician was there. The first name I forgot, but this mathematician in the field of group theory. So in the field of this abstract algebra, there was this mathematician whose name was Abel. His name was Abel. You can just check what is the name. I don't know. Okay, so there was a mathematician. So his name is Abel. Okay, and to tribute, like, okay, to give tribute to this mathematician. So this commutative property is named as abelian. Okay, so whenever you see this abelian word, abelian, if you see this abelian word, this automatically means commutative. This is associated, this word abelian, this is associated with commutative. Okay, so tell me what will be the definition of, for example, abelian semigroup? What that will be? Can anyone tell me what will be abelian semigroup? Abelian semigroup, what that will be? That will be semigroup plus commutative property. Abelian, this means commutative property. This abelian will give you commutative property. Okay, and this semi group will give you closure property plus associative property. So if these three properties are there, then we will call it abelian semi group. So remember, okay, this abelian word, this word is associated with commutative. So for example, what is abelian monoid? If I ask you what is abelian monoid, abelian monoid, another name is commutative monoid. So I can simply call it commutative monoid, correct? Another name is commutative monoid. Similarly, another name is commutative semigroup. So this word abelian, this is associated with the commutative property. So this is just a tribute to this person, this mathematician was there, his name was Abel. So anyway, similarly, you can say abelian group. What is abelian group? This is most popular. Most of the time we talk about abelian group. Okay, and this is the most popular thing. Abelian group. What this means? This means group. So basically group plus abelian. So I can say this is your commutative group. This is your commutative group. Okay, commutative group. It simply means that in a group you have commutative property. So abelian group will have closure property. This will have closure, and this will have associative, and this will have identity property, and this will have inverse property, and plus there will be commutative property. Okay, so this is the idea. So these four means group. These four means group. And if you add this commutative, then it will become abelian group. So very simple. All these properties, commutative, closure, associative, identity, inverse. This type of group is called abelian group. All the properties that we have seen. So you can notice one thing, that binary algebraic structure. What is the another name for this? Binary algebraic structure. The another name is magma. The another name is magma. Some people use this word groupoid. Okay. So anyway, you can notice one thing, that every semi group is a magma. Every monoid is semi group. Every group is a monoid, right? So this is the idea. So I can say that every group is monoid, every monoid is semi group, every semi group is magma. Correct? So that's the complete idea. Okay, let's move on. So we have already seen what is a groupoid. Groupoid, basically another name is magma. So it simply means that you have non-empty set and there is a binary operation. Basically it means closure property. So you can notice that this set of natural number comma addition, this is magma. Set of natural number comma multiplication, magma. Integer comma addition, integer comma multiplication, these are also magma. Rational number comma addition, rational number comma multiplication. So all these are basically groupoid. Set of natural number with subtraction, this is not groupoid. Next, what is semi group? Semi group means associative and closure property plus associative property. Like this addition, this addition is associative, multiplication is associative. This is not semi group. What is the reason? Can anyone tell me what is the reason? This is not semi group, and what is the reason? Not closed. This is not closed. Also, this is not associative. Subtraction is not associative and not closed. So the reason is not closed, not associative. Both of them. And what about set of integers comma subtraction? This is closed. You know, the closure property is there, but this is not associative. You know that subtraction is not associative. So what can I say about this structure? Which name should I give to this structure? इस structure को क्या नाम दूं? So that is magma. Okay. Or groupoid. Or simply algebraic structure. What is monoid? Monoid has identity. Monoid also has identity property. So there should be identity property also. Now, let's see this one. The following are example of commutative monoid. You can notice. For example, see, this is the example of commutative monoid. N comma multiplication comma 1. What this means? Can anyone tell me what this actually means here? Because remember, because monoid has this property, monoid has identity element. Because monoid basically, monoid means identity element. You should have identity element, right? Okay, So because monoid means semi group plus identity element, you have a semi group plus identity element plus identity element. So this monoid is sometimes this is denoted, this is represented like this. Okay, some people they represent this represented, this is represented like this. You have this set, you have this operation and this identity element. That's it, very simple. So this is how some people represent. Okay, because this monoid means identity property, there should be identity property for monoid. So some people they represent like this. So for example, what this means, this simply means that yes, this is a monoid, and you can notice this is commutative monoid. So I can say this is commutative monoid because this is commutative, multiplication is commutative, and this is monoid also, and this identity element is 1. This is the identity element. Okay, so that's it. So these examples you can check it out, all of them are commutative monoid, like this set of natural number multiplication, set of natural number. So here remember this, here the set of natural number is actually whole number, here actually the set of natural number is this, because I told you that this is author dependent. Some people, some author they consider 0 as natural number. So in this example, set of natural number is basically this 0, 1, 2 and so on. Okay, so this is the idea, you can check them out. Let's move on. So let's see this example. On set of natural number, you are defining this operation. Tell me what is this structure. On set of integers, this operation is defined, and this operation, what this operation is doing, this is doing a minus 3 plus b. So basically this means a plus b minus 3. Okay, tell me what are the properties. Is it closed? First to tell me about the closure property. Yes, closure property is there, because if a comma b are integers, if these are integers, then a plus b minus 3, this also will be integer. So the closure property will be definitely there. Okay, and what about the associative property? What can you say about associative property? Can I say associative property will be there? For associative property, you need to do this. You need to check whether this is equal to this. You need to check. Without checking, don't answer. If you are answering without checking, then one day you are going to make a mistake. Let me tell you. If you are answering without checking, so check this. So this is what you need to check. A star B star C, is this equal to A star B star C? Is this equal to this? Okay, so this is what you need to check. So let's check. What is A star B? This is A plus B minus 3 star C. Now what that will be? This will be A, this will be A plus B star C. It simply means A plus B minus 3 plus C minus 3, correct? Yes or no? So this will be the idea, because this star C, it means this plus C minus 3. Okay, what will be this? This will be B plus C minus 3. What will be A star B plus C minus 3? This will be this plus this minus 3. So that will be A plus B plus C minus 3 minus 3. Are they same? Yes, they are same. So I can say, yes, this is associative. So associative property we have. So closure property, associative property, both of them we have. What about identity element? What can you say about identity element? A star B is equal to A plus B minus 3. What can you say about identity element? What is the identity element? See, just apply the definition. Please apply the definition. Okay, just apply. Okay, so let's assume E is the identity element. Then by definition, what should happen? A star E, this should be equal to A. Just apply the definition. A star E, that means A plus E minus 3 is equal to A. And from here, E is equal to 3. So you can check E is equal to 3. You also have to check this. A star A is equal to this. So this will be E plus A minus 3 equal to A. And from here also E equal to 3. So I can say this, yes, E equal to 3. So identity element will be 3. And you can cross verify. Remember, you can cross verify. Sometimes this is very useful. You can cross verify that E is equal to 3. Verify that E is equal to 3. So tell me what will be E. this, what that will be? That will be a plus 3 minus 3, and that will be a. Okay, so that's the idea. So this is the cross verification. You can verify that yes, e equal to 3 will be the identity element. So this is the cross verification. Okay, what about the inverse? Can I say inverse property? What can you say about inverse property? Can I say every element has inverse? Let's check out what is the inverse of a. What is the inverse of a? Apply the definition. This is the definition of inverse. By the definition, this should happen, and e is equal to 3. You already know. This is the definition. Just apply the definition. So you will get a plus a inverse minus 3 is equal to 3. So from here, a inverse is what? A inverse will be 6 minus a. Okay, the same thing should happen in the other side also. But because it is commutative, so you don't have to check. Actually, see, you don't have to check the other side. Why? Can anyone tell me why you don't have to check other side? Because actually it is commutative. This structure is commutative. You can very easily see this structure, this thing is commutative, right? This thing is commutative. So because this is commutative, so you don't have to check these. This you don't have to check, because E star A will be same as E star A. Agree or not? Yes or no? See, this and this, they will be same because this is commutative. A star B is equal to B star A. What will be B star A? B star A will be B plus A minus 3. Both are same. So that's the reason I can say this is commutative. And because it is commutative, you don't have to check. Okay, so very simple. So inverse property, just check this. Because of commutative, you don't have to check the other thing. So A inverse will be 6 minus A. Cross verify. Just cross verify that every element has inverse. So tell me, for all A belonging to Z, can you just verify this? What can you say about A star 6 minus A? Is it equal to 3? Is this equal to 3? Let's check. So what can you say about A star 6 minus A? This will be A plus 6 minus A minus 3. And that will be 3. And that is equal to identity element. So this is the cross verification. Sometimes it will help you. So finally, what can you say finally about this structure? What is your final answer for this structure? Set of integers star A star B is equal to A plus B minus 3. So what is the final thing? This is abelian group. I can say this is abelian group because this is commutative also. So this is abelian group, commutative group. Okay, so very simple. Here remember, A inverse is 6 minus A. So here, for example, what is 5 inverse? What is minus 10 inverse? Tell me. A inverse is actually 6 minus A. So if I ask you what is minus 10 inverse, that will be 6 minus 10, and that will be 16. Okay, so if I ask you what is 10 inverse, then that will be 6 minus 10, that will be minus 4. Like this. So just take care. Let's see the next question. So this question is done. This is a abelian group we have seen. Let's see this question. So this question you can take as homework. Quickly tell me. You can take this question as homework, but let me give you the quick answer. So tell me, what do you think? First of all, you tell me what is the base set. Anyone want to tell me what is the base set? Remember this operation is from n cross n to n. So your base set is set of natural numbers. So first of all, this is your base set. Okay. So actually on this, this is your base set. So your structure is like this. This is your structure, and the structure is like this, that A star B is equal to A power B plus B power A. And let's assume that set of natural number is this 1, 2, 3, and so on. Now, what do you think? Is this closed? Is the closure property satisfied by this structure? Let me quickly give you the answer. A star B is equal to A power B plus B power A. The closure property, yes, the closure property will be satisfied. Correct? Because this also will be natural number, this also will be natural number. If you have two natural number, then, so basically if you have two natural number, then then a power b is also natural number, b power a is also natural number. So that's the answer. Okay, so their addition is also natural number. What can you say about commutative property? Tell me about commutative property. Yes, this is commutative also, because a star b is equal to b star a. What is a star b? That is a power b plus b power a. What is b star a? That is b power a plus a power b. So yes, both are same. So this is commutative also. And what about identity element? Tell me about identity element. What that will be? Is there any identity element here? Just apply the definition of identity element. Identity element means that this should be same as this. It simply means a power e plus e power a. This should be same as a. Is there any element? Is there any element which will satisfy? For example, e equal to 1. Will it satisfy? For example, e equal to 1. Will this satisfy? No. Because what is a star 1? That is same as a plus 1. A star 1, that is not equal to a, right? That is not equal to a. So whatever number you take, for example, e equal to 2, you take e equal to 2. So what is a star 2? That will be a square plus 2 power a. Again, that is not same as a. So you can notice there is no identity element. Identity element is there, which does not exist. Okay, so there is no identity element. So in this question, you can just check it out. There is no identity element. Okay, is it clear? Because you can notice this one was getting closed. This one, if you check this e equal to 1, then what will happen? Then you can notice that a star 1, that is same as a plus 1. Because what is a star 1? A star 1, that is simply a power 1 plus 1 power a. And that will be simply a plus 1. That's it. So this is not same as a. So there is no identity element. If there is no identity property, then what can you say about inverse property? What can you say about inverse property? Inverse property is also not there because there is no identity element. If there is no identity property, then inverse property is also not there. So finally, what can you say about, and what is associative? Is it associative? Is it associative? So let me just check. Let's check for associative. Let me check with this example. Let me take 1, 2, 3. Let me take this 1, 2, 3. So finally, what will be 1 star 2 star 3, 1 star 2 star 3? What this will be and what this will be? Can anyone tell me? Are they same? What this LHS will be? This will be 3. This will be 3 star 3. That means 3 power 3 plus 3 power 3. Okay. So that means 54. And what this will be? This will be 2 power 3 plus 3 power 2 star 1. So that will be 2 power 3 plus 3 power 2 plus 1. Okay. So finally it will be what? This is definitely not 54. This is definitely not 54. So this is not associative. So associative property is not there. So first of all, associative property is not there. You can just check it out. So because it is not associative, so finally what can you say? What name can you give to this structure? So this structure will be called what? Set of natural number comma star, and where a star b is already given to you as a power b plus b power a. So this structure is what? This structure is commutative magma. So these questions you can take as homework. I will do this question. Okay, so one question I will do. Total 6 questions you have. Binary operation on Q. Q means set of rational number. This Q simply means, remember, this Q is a set of rational numbers. Set of rationals. So these are your questions for your homework. You can discuss these questions in the group. Okay, so let's take this as a homework. But one question I want to discuss. For example, let me discuss this AB by 4. So tell me, so on set of rational numbers, you are defining this AB by 4. This new operation you are defining, and you are saying that A star B is equal to AB by 4. Is it closed? First, closure property. First you understand this operation. So tell me, what is 3 star 4? What is that? That is 3 into 4 divided by 4, and that will be 3. So 3 star 4 is actually 3, right? So this is the understanding of the operation. What about closure property? What can you say about closure property? So if you have two rational numbers you have. So let's assume you have rationals, like for example, P by Q, okay, maybe A by B, C by D. Let's assume you have these rational numbers. These are your two rational numbers. Then can I say that this AB by 4 will be rational? Yes, this also will be rational. Then in this situation, definitely you can notice that this AC by B, okay, so this will be rational. A by B multiplied by C by D divided by 4. This is also rational. Okay, so we have this closure property is definitely satisfied. What about associative property? What can you say about associative property? Is that associative property satisfied? Can I say A star B star C? Can I say this is equal to this? So what is this? This is AB by 4. Okay, and what is this? This is A star BC by 4. And finally, what this will become? This will become ABC by 16, right? This will become ABC by 16, and this also will become ABC by 16. So both are same. So yes, this is associative. What can you say about identity element? Is there any identity element? Apply the definition. Okay, just apply the definition, you will get your identity element. So basically AE by 4, A star E. What this means? A star E. This simply means AE by 4. This is equal to A. So from here, which E will satisfy? What value of E will satisfy? E equal to 4 will satisfy, right? So you can, this is the cross verification, verify. You can also do the cross verification. If you have any rational number, for example, let's assume A by B. If you have any rational number, of course, B is not equal to 0 because it is a rational number. So if you have any rational number, then you can very easily see that A by B star 4, is it equal to A by B? Are they same? Yes, of course, because it will be AB by, okay, AB into 4 divided by 4, and the whole thing is equal to A by B. So this is your identity element. What is the inverse? Anyone? What is the inverse? Like, okay, what is the A inverse? What is the inverse of A? Define on set of natural number, set of, can I say inverse property is there? Is there any inverse property? For example, if I ask you what is A inverse, so let's assume A inverse is B. Let's assume. What it means? It means A star B should be equal to 4 because this is the identity element. So it means AB by 4, this should be equal to 4. From here, B is equal to what? From here, what B will be? 16 divided by A. Correct? So here B will be 16 divided by A. But tell me, now from here, tell me, what is the zero inverse? Like, let's find out zero inverse, what that will be. Like with 0, what should I put such that I get 4? With 0, what should I put? What should I put such that I get 4? It means 0 multiplied by 4, 0 multiplied by this divided by 4 is equal to 4. What should I put here? So this B does not exist. This B does not exist, right? So this inverse property is not there. Remember. So you can clearly see that zero inverse does not exist. So these corner cases, remember these corner cases, don't forget about them. But if A is not equal to 0, then A inverse will be 16 divided by A. Then that will be 16 divided by, okay? If some number is not equal to 0, then you can say that this will be 16 divided by A. Now from here, I can create a question. Like if your base set is set of rational number minus 0, non-zero rational number, and this operation you have, this A star B, this operation you have. Now you can clearly see that what will happen. Now this will be, you have identity element, all these properties are satisfied. Now every property is satisfied. You have identity element, your identity element is 4. Inverse also is there. What is A inverse? That will be 16 divided by A. Okay, and is this commutative? Yes, this is commutative also. This is commutative also, because A star B is equal to B star A. What is A star B? This is AB divided by 4. What is B star A? This is BA divided by 4. So yes, they are same. So finally, I can say that this structure is a abelian group. But what can you say about this structure? So finally here, this Q comma star, what can you say about this original structure? For this original structure, I can say that this is only abelian monoid.